Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra, dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to verify basic proportionality theorem. For preparing this video lecture, I used Windows 10 operating system, licensed version, GeoGebra 5.0, a free open source software, and a free open source screen recorder software. Let us start. Before that, I will show you what type of worksheet we will be presenting over here. Basic proportionality theorem. First, we will declare the statement. Line is parallel to side of a triangle which intersect the other side into two distinct points. Then a line is the line divides those sides in proportion. Well, we will take a triangle, we will take a point on it, and we will draw a line parallel to BC. It will touch us at E. We have to tell that AD by DB is equal to AE by EC. The other proportionality automatically it will come over there. And we will tell them the value to the children also, and we will ask them to come and drag it and check out by dragging this B also, by dragging this D also, what really happening. Okay, now the child can understand what is the meaning of this basic proportionality theorem and what is the meaning of that ratio also, and they can explore more out of it. Let us try to design this worksheet from scratch. For that, I have taken GeoGebra 5.0 worksheet. I have selected geometry view. In the option, I have rounded off to 2 decimal place and labeling of new points only. I will have this navigation bar ready with me so that the steps I can go for it. Okay. Well, in the heading, I will I will go for this ABC. In the heading, I will type basic proportionality theorem. Well, it will come over there. Now the statement I already typed and keep it ready so that I can copy it to avoid to save time. I will put it over there. You can type it or you can type it also. That it will not take much time for you to type it. Okay, now here you see we are going to draw a triangle, a general triangle, and then we will try to prove this basic proportionality theorem. For that, we will start now. We will go to this polygon. We will go for the polygon A, B, then C, and then come back to A. Make it this A come down and B come down and C come down. We have to take a point on this triangle. Point on object is the better option to take because when you come and put it over here, it will stick to it automatically. Therefore, no need to worry whether it is inside that or not. You see, it moves along this only. Suppose if I right click it and then put animation, you can see it is moving along the triangle, which means that it lies on the triangle. Suppose if you take a point and put it over here, sometimes it may not be possible for you to just stop it. Okay, well, now that the point which I have taken, that point is lying on the left side. Therefore, I will stop its animation. Stop its animation and put it over here. It's a moving point. That is a thing which you have to be very careful. Okay, well, now what is the thing? We have to draw a parallel line through this D to the AB. Therefore, go to it. This perpendicular line, there is a parallel line is there. Simply touch this D. You want it parallel to AB. Okay, you got it. Now, let it touch at another point because it has to divide. Therefore, we will go for point of intersection. Carefully touch this line and then touch this triangle. A triangle or that BC, whatever may be. Therefore, you got that D, E now. Now you are seeing here that A, B, C, D are in blue color and E is in black color. Already we have discussed it. E cannot be moved by you, but you can move A, You can move B and A, and you can move this D, and you can move this C also. Okay, well, now what is thing which you have to prove now? We have to prove that AD by DA is equal to EC by BC, BE by EC, whatever it may be. AD by DC is equal to BE by EC, whatever way you want to do it. But what we can do it is we can find their lengths also. For that, let us declare that statement. What the statement now? For that, better to use this latex formula. In the latex formula, you are having this A by B. In place of A, I will type AD, and in place of B, I will type in any way you can put. I think suppose if you want to put CD by DA, that also I will do, no problem. CD by DA is equal to, once again in the latex formula, go for this A by B. There you have to go for CE by EB or BE, whatever maybe. Okay, I'm just putting it. I'm just declaring it to the children that CD by DA is equal to CE by EB always. For that, I want their lengths. Go to this segment. First, carefully go and put this segment. Then again go and put this segment. Again go here and then put this segment. Go from E to B and then put that segment. Now you remember you want this length of this segment, but here when you go and touch it, you may have some confusion. But go to this graphing. In that graphing, you see all of them are here. GHIJ. Right click it. Go for this object property. It has been done in order. Go to this label and then a name and value. Okay, you got it now. Again touch it. Again name and value. Got it. Again touch it. Because it is already open, that property is already open, therefore you will get it very quickly. Go for it. Then once again show label, name value. Well, good. We will come back to the geometry. This graphing is being used only to do it very quickly, so that identification of these segments are very easy for you. Okay, now what you have to do now, this G by H is equal to I by J, you have to prove it. Therefore, what you can do is we can go for this text once again. For again, we will just write their value because these values are going to change. This latex formula once again, A by B. In place of A, you delete it. And then from the figure, you are having it as G. Therefore, you substitute G here. Then in place of B, you delete it. And what you have to do now, you have to put H. From the figure, I think the figure is in the left side, for I am able to locate it, is equal to, these are all variables. Once again, latex formula, A by B. You have to take I. CE is I over here. Therefore, delete it. Then go for this I. Okay. Then again, select this B, delete it. And go to this object and go for J. It is J is over here. Okay. Now it has come over here. Okay. Now you can very well see, suppose when I move this, you are seeing that that 3.85 is moving. When I move this, the first fraction is moving. When I move this, both the fractions are moving. Now we want to get their values. You have to get their values. What you have to do now, you see here you have got GHIJ. Therefore, you have to go for another variable now. Go to this view, then keyboard. You have to keyboard, you can do the calculation. But if you want to just show the calculation, go for this input bar. In that input bar, now you fix small h. So better in that go to this graphic view and then check whether h is not anywhere. H is not anywhere, na? I don't think here GHIJ. Therefore, k is not there. Or I can use k. Okay. Therefore, many problem because GHIJ, the next alphabet will be k. I will be using k. Therefore, go to this view, go to this input bar. In the input bar, you type k is equal to small k, better use small k. Small k is equal to G upon H. Simple. Okay, that value has come. Don't worry. Therefore, what you have to GHIJ k, okay. Then L is equal to, once again, we can have I by J, I slash J, I by J. Okay, okay. Now you can come back to this geometry graphic view and then check out the values are same or not. You see, both are same. 7.6 and 0.76 and 0.76. But when I move this, okay, when I move this, Okay, when I move this, oh, that 0.76 is actually not at all moving. But when I move this, that will change. Okay, because you know that the ratio has to change whenever I change the position of it. But it is not changing anywhere. Okay, now let us just to put it here also for the children to check it out. Now you remember what are the variable you have fixed there. The variable I have fixed is, you have to remember that K and L. It is K and L. You have to remember that. Okay, go back to this geometry and come back to this ABC text and then put it over here from the object K and L. Therefore, K is equal to, then from the object you have to take L. Okay, I think both of them should be equal and it will be automatically equal to 1. What I can do is I can put all of them over here so that that line will not disturb me. Okay, well. Okay, now you can ask the children to come and pull and push. You can ask them to check whether the ratio is always equal. Be careful. Whenever I am pulling and pushing it, only the right hand side CE by EB will change. When I pull and push it, CD by DA will change. When I push it, both of them are changing. When I do it, the ratio changes. Therefore, if a line is parallel to the side of the triangle, which intersect the other side at two distinct points D and E, the line divides those sides in the same ratio or divides it in the proportion. It's a very highly interesting idea now. Thank you. Let us learn to lead.